Alright, 315 was a little bit confusing because you had to go through all that math to figure out the correlation coefficient. But the main thing I want you to get out of there is the correlation coefficient and to be able to interpret those graphs. So first, let's look at the graph. So we changed it into the logarithm scale of gene expression, but instead, so you're not going to have to do that. I'm not going to make you give calculations to do that. What I want you to do is be able to interpret the graph. So instead of this tumor suppressor gene down here being below, in between 1 and 0, we actually made it negative, and it gives a little bit better representation of what it's doing. So it is negative in cancer cells, meaning it is off, but it's on in normal cells. These two are on in cancer cells, so they're high, they're positive, so they're oncogenes, but they're off in normal cells. So that just gives you a better representation. So you just need to know that anything above the axis, the x-axis here, are oncogenes. Anything below are tumor suppressor. So now the correlation coefficient. So the numbers, more numbers you have to remember. 0 to 1. So 0 is no correlation. All right, so there's no pattern between the two. These genes are not related. So zero correlation is if none of these genes are related. So for example, whenever this one was on, this was off, but then this one was on and that one was off, and they were both off. There was no pattern between these genes. All right, but that's not quite what we see. We see a slight pattern here with these genes. And then when you get the correlation coefficient, you're either going to get a positive number or a negative number. The positive number means two things are behaving in the same way. All right, so these two genes, gene 1 and 2, are behaving the same way. They're both oncogenes and they're both going slightly up. Each patient got slightly higher gene expression ratios. So these are behaving the same way, so they have a positive correlation. All right, and a positive correlation, as you get stronger, close to 1, 1 is perfectly correlated. And I'll describe that more in a second. And 0, or closer to 0, it's very weakly correlated. So there's maybe a slight pattern, but not really. All right, and the thing you have to understand with these correlations too is that it still doesn't mean one is causing the other. It just might mean that that is happening, but it's not necessarily the case. Then the other side is a negative correlation. So these, gene 1 and gene 3 here, are negatively correlated because whenever this one's on, this one's off, they're behaving in opposite manners. And same with this one. Whenever this one's on, this one's off. They're behaving the opposite way. All right, so those two have negative correlations. And then you can have a perfectly negative correlation as you get closer to -1, and a weaker as you get to 0. So it's almost like the pH scale where you have neutral in the middle, and then either way you get stronger. All right, so you have 0 in the middle. As you get more negative, it gets a stronger correlation. More positive, you get a stronger correlation. All right, so if we're trying to look at genes and see if there's a pattern between them, you probably want to look for probably a 0.85 or 0.9 or higher to really know if there's a really significant pattern there. So this is just kind of put this in picture representation. No correlation is, you see how this graph is? There's no pattern here at all between these dots. When one increases, it might decrease, it might increase. All right, there's no pattern between the way these two factors are behaving. This one, they're both, as one increases, the other one will increase, but there's no real pattern between that, because here this one increased a little bit, but this factor increased a lot. Here increased a little bit, and this factor increased a little bit. So there's a slight pattern, but it's weakly correlated. So you see how all these dots are far away from that line. So this is closer to 0, whereas this is closer to 1, because now you see this one increase a little bit, this factor increased here, or increased there. All right, so there's about the same pattern. Once you go up this far, it goes up about this far. All right, so these dots are closer together, so they're a stronger pattern, so it's closer to 1. And then the negative correlation is the same way. No correlation here. Going downwards, there's a slight correlation. When one decreases, the other one will increase. So this one's increasing, this thing's decreasing. And same here, but there's a stronger pattern. You see how when this one decreases a little bit, increases a little bit, and this one just decreases just slightly, and they're about the same level here as one decreases or increases. So these have a stronger correlation. All right, so that's really you have to understand is just this correlation coefficient and what these numbers mean. That these there's a stronger pattern between what is happening here. So these are the genes that we're probably going to be more focused with, where there's a very weak pattern and there's probably nothing affecting them.